Hi, again. How's it going? My name is Yina. I lead product for Azure AI Foundry. I'm here with Paul. He leads our engineering team for all of our SDKs and APIs and evaluations. And today we're going to show you everything you need to know as a developer to work with AI, agents, models, tools, vibe coding. We have a very packed session. And we're going to start with the scenario that we're going to use. So we're going to build an end-to-end application. Imagine you're, of course, a Contoso developer who's trying to figure out how do they get input data from invoices and then put that into set of like images and PDFs and then process that data structure and then have an application that the end user gets to interact with. So this is the application that we're going to build through this session. And we're going to, of course, use Azure AI Foundry to build it. So before we get there, Azure AI Foundry, it's all you need to know when it comes to building and injecting AI into your application. It starts with models, bringing you the richest model catalog out there in the industry across state-of-the-art models from Azure OpenAI to other leading model providers like Mistral, like Grok, like Black Forest Labs, like Meta, like NVIDIA, and many more. Then it goes to agents and giving you the end-to-end platform that you need to build agents to not only use the latest frameworks and connect them and interrupt them, but also being able to deploy them in the service where you don't need to worry about managing and scaling them and doing all of the bringing in all of the set of service art features for you. Then we have a set of services that you can use that enable you to connect to data in search, connect to set of AI services like speech translation, content understanding, and other set of capabilities that we've been building throughout a long time. Then we also have not only model consumption and model customization, but also model creation with Azure Machine Learning. And then, of course, all of the features that you will need in order to safely and trustworthily bring your applications into production with content safety. All of that with a set of tooling that enables you to take your ideas to code and your code to production with observability, bringing you tracing, monitoring, evaluations, and all of the end-to-end tool chain that you need and integrate it fully with Azure capabilities. Now, let's show you how to get started. And for that, I'm going to go to the Foundry portal. So the first thing that you're going to see on the Foundry portal is the model catalog. Here's where you can find all of the different set of models that Azure AI Foundry has to offer, including our new models from Grok 3. One of our new announcements is the model router, which is basically a lot of times you're like, where do I start when it comes to selecting a model? OK, you have a lot of them in the catalog. And there's the easiest answer to that is we have a new offer. It's called the model router. Let's check it out. That is the best way for you to try different set of models, because the model router, what it does is takes the prompt, analyzes the prompt, and based on how complex the prompt is, it will send it to a simpler model or to a more robust model. So here I'm going to go through the flow of deploying the model. I'm going to deploy model router. I'm going to choose the deployment type global standard, which means the model is going to run. The request is actually going to be processed anywhere in the world. And I get an error because I'm not in the right project. I'm just going to cancel this, and I'm going to
go to the second tab.
Go to the second tab. Thank you, Paul. And I'm going to go through the deployment of model router. And part of doing this is going to take the model. I'm going to be able to open it in the playground and start making prompts to it. So if I ask something very simple, what is the weather in May in Paris, it's going to use a very simple model, for example, a nano model. In this case, it used a GPT-4o. But if I ask more complicated questions, it will then use a model like a reasoning model, like an O1 model, or it will use a simpler model like a GPT-4o model. OK, that's model router. And one of the other things that I wanted to show about models is the broad selection of models that we have. It includes models across different industries. So for example, consumer, financial, healthcare. It includes models that like support different set of tasks, like whether it is classification, text-to-text, speech-to-text. All of these different set of models provide different set of capabilities for your scenario. One of the things that we have is the model leaderboard, where you can see the latest models and the top models and how do they interact when it comes to quality, cost, throughput, and like helping you make decisions depending on like, do you want a higher quality model and like, you know, whether that it can have a bigger throughput, or do you want, for example, a comparison between quality and cost? And that way you can see the different set of like, the different set of dimensions that you will use to make a decision on which model to choose. But enough of the portal. Let's try building our first agent in code. And for that, we're going to go to VS Code, and we're going to use the Azure AI Foundry extension, VS Code extension, to do that. First, that you can see in the VS Code extension is we have here all of the different set of models as well that you can use serverless. And we're going to start with an agent creation flow.
So let's get started building an agent, Yina. We're just going to call this one our invoice agent. So we talked about earlier having some data that we want to then query over. Let's also make an agent to generate some invoices for us and see what that would look like. So here I'm using the extension. I'm going to use GPT-4o to generate those. You have some simple instructions like a sample invoice for me. Use synthetic data.
This is a good point to say, like agents are actually a set of instructions, a model, and a set of tools that the model will use to call based on the prompt that is coming into the agent.
Absolutely. So let's go create that in the Foundry. So it's deploying right now. It's created for us. Let's go back to the portal where we just were and go find that same agent. Here it is. So let's try it out, Yina. So let's do home construction.
So right now it's going to use the GPT-4o model, take the prompt, and then like generate an invoice based on synthetic data as we give it in the instructions.
Absolutely. Here it generated a sample, made up some data for me, spit it out in Markdown. It looks great.
Fantastic. OK. Now let's go back to our slides. And so we saw how easy it is to get started using AI Foundry, selecting a model, starting in VS Code to build an agent. Now, one of the things that it is important to note is Foundry offers an open ecosystem, an interoperable ecosystem. So whether you're building agents on Foundry or whether you're using agents from other providers, you can use protocols like agent-to-agent, which is like a protocol that enables agent-to-agent communication, or a model context protocol, which is a protocol that enables the agent to invoke certain set of tools, as well as use any API that has been described with an open API description in order to invoke that particular tool. And in a minute, we're going to see how we're going to start adding tools to the agents so that you can see this in action. OK, for the rest of the talk, we're going to focus in two sections. First, we're going to go into the inner loop. So as a developer, how you go through the building process. And then we're going to go through the outer loop. Like once you have your application, how do you make sure that you add tracing, monitoring, that you can fully debug it, that you can integrate it with your GitHub CI/CD pipelines, and have that end-to-end lifecycle across as I mentioned before, idea to code, code to production. One of the things that we wanted to mention is, if you've been an Azure AI customer for a while, a lot of our products are an evolution of what we have been building. So we started with machine learning, Azure Cognitive Services, and as such, there is several resources that were attached to each of one of these services over time. Now, as Gen AI has come in, we want to greatly simplify the development experiences, bringing all of these services together, so you don't have to manage all of these different resources. So one of the things that we've done over the last few months is like do a lot of consolidation of this process to make sure that we go from 5 different resources that you need to manage to only 1 resource, to like many minutes to start, to like many clicks to start, to just a few clicks and just a few lines of code. And like consolidating all of our API structure into a single API. And we're going to get to see those APIs in action today. OK, let's go back to the demo. We created the first agent with that input where it takes a prompt and is going to generate the invoice. But we want to do a little bit more than that. So let's go back to our demo.
Let's do it. So first, we're going to walk through building a more complex agent here, kind of step by step, and see what that looks like in action. First thing we're going to do is we generate invoices in Markdown. We also want those as images, as ping files, to show how you can work with that data too. So we're going to add one of the many built-in tools that we have here as part of the agent service. Specifically, we're going to add the code interpreter tool. So code interpreter lets me run code in an isolated environment so that when it can go then generate Python code, execute it, download the results, or do whatever else it wants. A few others are here on the screen, including calling other OpenAI API tools, calling things tools through logic apps, and more. So let's add the code interpreter. We won't add files. And our code interpreter is ready for action. So, I'm generate another invoice and give me a ping file. So the agent in the background is going to look at the tools it has available, try to figure out what it needs to do in order to address my question here. And it called the code interpreter. You can see here, it actually gives you the code back that it ran, and it then gives me the result. So I can download a construction invoice. Let's go take a look at it and see what it did. So here we have, and I'll zoom in. Here we have a simple invoice. It's kind of getting the job done. It's not doing great, but it's a good start.
OK, so now we have an agent. Is using a model, a GPT-4o model, is following the instructions that we are giving it to generate the invoices, and we've added a tool called Code Interpreter. The next thing that we're going to do is we're going to create the second agent. The second agent is going to take all of that information and add it to a knowledge base. The point that we want to communicate here is that there is a way to both handle structured data and unstructured data. So we're going to use Cosmos DB for all of the structured data, and we're going to use Azure AI Search for all of the different set of unstructured data.
Absolutely. So let's look at some more code, Yina. So we want to take this agent, go to code, and start working there. We have functionality to view code here that lets you make the transition simpler. We're going to look at Python today, but we also offer C#, JavaScript, and more. And with that, let's look at this same project.
Let's open that. Let's open the view code.
Let's look at it.
So you can see the code coming in here. You can open in VS Code on the web. We have multiple languages that are supported, Python, C#, and JavaScript. You can use this as a getting started for your application.
Mm-hmm. In fact, this is how we started with this application that we're going to look at right now. So let me close this. And close the model catalog. I'm going to start a script running in the background, and then let's talk about what it's doing while it runs. So here we have a script to generate invoices and save them to Cosmos DB and to Azure AI files. To Azure AI Search. It's doing a few things. I just want to point out the pieces, kind of what Yina was mentioning earlier. We have part of the Foundry SDK as a project client. This connects to your Foundry project, makes it easy to work with it, but whether that's inferencing models, evaluation, observability, all the pieces are here. And it's easy to get started and easy to use. So I just need one endpoint out of the UI, and I can connect here. Now that I'm defining things in code, I also need tools. here I define that same code interpreter, just in code. Here I can create an agent to do the same thing that we wanted around generating invoices, but I've given it the tools, the same model we had before, GPT-4o. I give it a name, and I give it the same instructions. But we've used actually a lot more here because what we saw is the one it generated was okay, but we want some that are nice quality, where things are formatted in a certain way and so on. So I've taken some time to write instructions here, exactly how I want these to look.
And this is one of the things that as a developer you'll do, like trying to figure out the prompt and the right prompt so that the model gets the output that you want.
Exactly. That's actually where we spent most of the time for this demo. And the reason is we actually used GitHub Copilot to generate most of the code that you see here. Let's take a look at what that looks like in action. So here at the end, we've run the agent. We got the output. This is that same markdown. And let's see if we can generate some code too.
So you're using GitHub Copilot in agent mode, which is going to be creating a new set of functions into your code. And you're saying extract the fields, add the invoice date.
Yeah, exactly. We know that we have some fields we want to pull out. They're all formatted according to the instructions above. I don't want to type them all out. I just wanted to go figure this out for me. Mm-hmm. Let's go see how it does,
So GitHub Copilot is one of the products at Microsoft that we're building actually using Azure AI Foundry as well. As you can tell, is using the GPT-4o model, is coming in from the same set of models that we offer to you. And that tells you that like the platform that we have is proof-tested, planet-scale driven, right? Like Microsoft 365 Copilot is also built using Foundry. All of the different set of Copilots that Microsoft offers get the models from the same set of like platform offer that we have, which is Azure AI Foundry.
Yep. We have some code. Let's go take a look at that for a minute. So zooming in, it's trying to extract all the fields by regular expressions. So it's looking here at the top for the invoice number, then for the invoice date, the customer name, and some other fields. So actually it's doing a pretty good job. This was a good start. So I'm going to insert that here. At the cursor, it adds this method for me that I can go call to parse the markdown. Similarly, we could go generate code to insert this into 𝗦𝗲𝗀𝗀𝗀𝗀, and that's actually the code that we just ran. So let me show you that, because there are just a few differences. So this is that same file we were just editing with the final edits in place. The only things I really had to change were the regular expression parsing. Sometimes the agent generates fields with a slightly different formatting, and I needed to tweak the regular expressions a little bit. Otherwise, that's the thing we ran. So really pretty easy.
OK, let's see the next thing.
Let's do it. So if we come back here to we've run this. It's finished successfully. It's generated 5 invoices for us. The run is completed. It's parsed out some data for us, like this customer, 𝗦𝗽𝗀𝗀𝗀𝗀, an invoice in mid-April. It's written it to 𝗦𝗲𝗀𝗀𝗀𝗀 and saved it to an image file. So if we look at one of those, actually it looks pretty good. The formatting is much better. Data looks pretty good in terms of what we're looking for. One of the nice things we launched recently that also works with the agent mode is the Azure MCP server. So MCP is a protocol that lets an agent talk to tools, work with data sets, and do some other things. The MCP server lets the GitHub Copilot in agent mode talk to Azure itself. So let's see how that works here.
And you're going to use that to connect to Cosmos?
I'm going to use it to connect to Cosmos. I could go into the portal or write a Python script, but actually I just want to talk to it here.
So as a recap, we have an agent that takes instructions to generate invoices. It does it in Markdown. It does it in files. We're vibe coding with GitHub Copilot to use Azure capabilities to add those files and that Markdown, structured, unstructured data, into Cosmos DB and into Azure AI Search. We're in the Cosmos DB part.
Yep. So every time Copilot takes an action, especially it's an external tool that asks me for permission first, which I love because I want it to make sure it's doing the right thing against especially something in Azure. So I'm going to hit continue here, and it's going to go query that container for me. The other thing that I love actually is it remembers the context. So it takes the previous history into account. So I can tell it, here I use container demo 1. Earlier I could tell it I want this account or that account or something else, and it will remember that for me. So I don't have to tell it every time. And actually, the third thing I love is the natural language interface, versus programming and having to get all the details just right. It will kind of figure things out for me and then execute the query on my behalf.
So right now it's trying to query for all of the MCP servers and then looking at the connection with Cosmos DB.
That's right. And we got some data back. It did a nice job actually at both summarizing what we have to work with. So these are the fields available in the container. And it gave me an example. So, and we could ask it for more. We could say, hey, give me the markdown for the first item or something like that. Very nice interactive format.
Sounds good.
Cool. The last thing we wanted to show is now that we have markdown for a set of these, we've added some nice features to Foundry. We want to show how you would summarize one of those markdown files. So we have here a simple check completion program using the Azure OpenAI client library to talk to Foundry. And we're just saying, you summarize invoices into a 1 to 2 sentence summary, and go summarize a single file for me. This is one of the files we just wrote out. And sure enough, it did that. GPT-4o gave me a summary for this invoice. Tells me a little bit about what's in it, not all the details. One of the nice things we're launching now is the ability to talk to DeepSeek through this same exact programming model. So what I can do is through check completions down here, I can say, I want you to use DeepSeek instead. That's the only line of code I have to change. Let's run it and see what our result is.
So both GPT-4o and DeepSeek are models that we have deployed, similar to how I deployed Model Router at the beginning. And then once you have those models deployed, you can go to your code and switch between the models that you're using with just a simple line of code, because all of those models are following the same API shape. So, and the SDK supports that API shape underneath the chat completions endpoint.
Absolutely. We got a good result back. So this gives me the ability to quickly switch between these models in my existing code base or an open source project or wherever I might be, and try out some of the different price performance comparison points. Mm-hmm. Let's take a look at the slides.
OK, so right now we've built the first agent, which takes all of the input data, the second agent that takes that data and puts it into Cosmos DB. Are we going to do the search part now?
Let's do some search.
Let's do some search.
So now we have the Cosmos DB database we can query. We also built a vector store on top of Azure AI Search. And I just need one piece of information, the vector store ID. So I'm going to use that, put that in here. And let's take a look at this code for a minute, and then we'll go query our database. Same code here to start by connecting to my project client. Same simple entry point. We'll talk about the monitoring in just a minute. Mm-hmm. Here I'm defining more tools because I know this thing has to query a couple different data sources. I also want to be able to take action on the world. So we're going to let it send emails on my behalf, say for overdue invoices. Here we're just defining it as a Python method. You could do it through Logic Apps or whatever existing system you have.
Or C#.
Or C#.
We also have a version of the SDK in C# and in JavaScript.
Exactly. The get overdue invoices uses Cosmos DB to get those overdue invoices based on 30 days past due. Here I added the file search to automatically query on that database we created. And we have code interpreter if we want to do that too. So here I have an agent with many more tools, the two local ones for sending emails and finding overdue invoices, file search, code interpreter, and I give it some pretty simple instructions around answering questions. But if you're doing this, if you're sending an email, please be polite and professional, talk to them by name and so on. Because I want this actually going out to the customer. And that's it. The rest of it is just to run the code. So let's see what happens. We saw here that we had one for 𝗦𝗽𝗲𝗸𝗀𝗁. Let's go see if we can find it. So again, same, this will just create the agent, run it. It will also pick out all the right tools for me.
What are some of the other tools that you added for this particular agent?
We added code interpreter so it can generate images too. Like if you wanted to say, create a graph of how many invoices you've had by day or totals by day, you could do that. Or if you wanted to generate an image for, to put into the email itself, you could do that too. It looks like it couldn't find it. I think that one's just a bug on our part, but we'll fix that one in a minute. But let's take a look at some other things you can query. This is a nice one because it involves orchestrating multiple tools. So it has to know, first you query for the overdue invoices, and then for each one of those, you have to go call the send email tool and process the data and be complete at that point. So it looks like it just sent one email for us. Here it is. It was April 15th. Today's May 20th, so this one's 35 days past due. So I think we got that part right. And with that, let's look back to the slides.
So recap again. We've been creating agents, adding different set of capabilities, doing all of that in Python. We had one that had input data, bringing in and generating the invoices, creating the markdown file, creating images, adding that to Cosmos DB, using GitHub Copilot. We also looked at how we use Azure AI Search to create a vector index with the images and adding an interface in which the user is going to be able to interact with that. Now, what else do you want to add to our demo, Paul, in terms of like all of the different agents that we're creating? We went through querying the agent, and I think we're ready to like take that agent to production.
To get to production, exactly.
Okay. Let's do that. And as part of taking the agent to production, well, before we do that, like there is a session that is going to go deeper into like all of the capabilities that Visual Studio Code offers. So like I invite you to go and join that session as well. And we'll look at how do we take it to prod. We talked about the inner loop. So these are all of the set of capabilities that you can do, like using models, switching in between models, using the SDK that we have for that. Now let's look at like how would you add tracing, evaluation, monitoring, and the end-to-end to take your application to prod.
Let's do it. So if we go back to the demo machine here. So we just queried our database. We're sending some emails. It would be nice to have some more insight into what's actually happening here, right? Because we want this thing to be getting the right answers, not going off the rails in some way. And that's where tracing is so valuable. So let's take a look at how we do that. Earlier, we talked a little bit about how the project client makes it easier to do certain tasks, and adding tracing is one of those. So in a project, there are things that are connected to it for doing other things, other tasks, and one of those is application insights, and that's a key part of monitoring because where we send a lot of the traces.
So all of that is integrated. If you've been using App Insights, it's the same integration. You send all of the traces to App Insights, and you'll be able to use the App Insights to do your queries across all of the data.
Exactly, that's right. All the great visualization tools and so on work. As part of that, we've added one line here to go get the connection string to your App Insights. And then there's one more line you need to call to actually configure writing all the traces out to Azure Monitor. And with that, we get the traces written out automatically as part of our application.
Let's show in the portal how a trace looks like.
Let's do it. So if I go to the tracing tab on the left, what we'll see is all the traces for the calls that we've been making. So this is the most recent one. And let's kind of dive in, Yina. And I think this is a good point to mention. As part of this, we depend on the open telemetry standard. So we write out traces in a common format that everyone understands, that other tooling can talk to and understand as well. And that way, it's easy to interact with in your application and do additional deep dives on. So here we get kind of like, it's like the debug logs for my Gen AI application. We created the agent itself. We did some things to it, like started a run. And actually, we can see even the queries out to Cosmos DB here. So this is it querying out to that structured data to find overdue invoices. And we can see info about the tools that it used. Here's the tool called back. And this is actually the returned result. So it's a Python list of JSON objects with things like the customer name, due date, and so on.
So across every single step, every single request that the agent is making, you're getting the full trace, inputs, output, all of the metadata, and we're also going to see shortly how you get evals.
That's exactly right. And so it's a good way to jump in and debug if something goes awry, or just try to understand, like, why is it calling that tool, or so on. And before we look at evals, we should actually look at tracing in the UI too, because we have some new things to talk about. Sounds there. Good. So if we go back to our agent playground for a minute. Let's use the same invoice agent that we made at the start of the session. So, and let me check all the metrics because we'd love to see everything.
So in this particular case, the metrics are part of like the evaluators that we have. And we have evaluators for both quality and safety. So do you want to share what are some of the evaluators that we can turn on?
Let's do it while it generates another invoice for us. So we have a few around quality, like is it giving us a coherent response? Is the response fluent, meaning is it natural language like? Is it relevant to the thing the customer asked us to do? We also have risk and safety ones like, does it emit harmful content? Is it violent? That kind of thing, because we know we don't want to send that out to our users. And one of the nice things we're launching now is the continuous evals. So every time I interact with this agent in the UI, I automatically get both the quality and safety risks here.
Right there in the playground.
Right there in the playground. And we can view the run info about what was this doing. And those same evaluations, here's what I asked it to do. Down below is the output that it gave me. And those same evaluations are also attached to that same trace. So we can come back and view those later if we want to.
So there is in this particular case, there is an LLM that is acting as the judge of all of the responses that are being generated by the agent, by the model that is being used by the agent. and it's using all of those evaluators, whether it is for intent resolution, whether it is for relevance. We have a new set of evaluators that we're announcing as well for task adherence, for indirect jailbreaks, like for example, when you want to connect with data sources like Bing that bring you the world knowledge, and making sure that like some of the things that you get back are not packed with some like code or something like that that is going to make the agent do things like that you're not intended to do. It will use an LLM to judge all of the responses and like bring you back all of those metrics in terms of like AI quality and in terms of AI safety.
Absolutely. So we saw how to do this in the UI, but let's look at it in code too.
Sounds good.
So in our project, one of the things that we have done too is we have a way to take the information from this agent, write it out to a common format, and evaluate that. So we can evaluate an agent, built-in AI agent service, or one from Semantic Kernel, or AutoGen, or a number of other frameworks that Microsoft also provides. To get there, after our run is complete for our agent, we actually just added one line of code to the AI agent converter. It knows how to talk to our project, and then one more line to convert a single run into a JSON format that we can understand for evaluation.
Can you tell us a little bit more about the converter and what exactly it's doing?
Yeah, absolutely. So it's reading both information from that run as well as the messages from the thread. It's pulling out all the detailed information, not only what was the input, what was the output, but also some of the internals like what tools did it call, what values did it pass, what did the tool do, was it successful or not. And then we use all of that, as you mentioned, as inputs to the LLM, which is judging on things like, did we understand what the user was trying to do? Yep. Did we get the tool calls correct, and so on?
Maybe one of the things that we haven't quite mentioned is like we've been talking about threads and runs. So a thread is that conversation that the agent is having, and run is each of the turns that are happening and the tool calls and all of that. So a thread will have all of the runs inside it, and like all of that information, we're using OTel, OpenTelemetry, to send it over to Azure Monitor and App Insights.
Yeah, good call out. And we store all of that in the agent service. Mm-hmm. Yeah. So let's look at evaluating this. So if I open up my evaluate agent script, this one's very straightforward. Here I read in that same file we just wrote out. And then we have 3 evaluators that we want to run on it. So the intent resolution, task adherence, meaning, we know what the user wanted. Did the LLM stay on task, right? Or did it kind of veer off in a different direction? And then the tool call accuracy. And let's go look at some data. So each of those evaluators returns a JSON object. So we can print it out and look at it interactively, or you can assert on it in your code if you want to know, like, okay, did this thing go off in some CI/CD pipeline or automated system, and send an alert or whatever you want to do there. Each evaluator has a range, intent resolution, or a range of its outputs, meaning here intent resolution is from 1 to 5, so 5 being the best. So this output is telling us we did pretty good on intent resolution at finding overdue invoices and sending the emails. It passed. The threshold for passing is 3 on this one. And it gives us a reasoning. It correctly understood the user's intent. It gives us kind of very detailed info, like the emails were professional. There was a minor issue with one of them, but that's okay. So it's a nice way to go understand more about what the LLM was thinking here when it evaluated this one. If we
let's talk about what are the actual evaluators that we have available. I mentioned we have evaluators around quality, so whether the response is actually grounded on the data that was provided. coherence is like the answer that is being provided actually like meeting the coherence expectations? Is it fluent? Is it relevant? What are is it when it comes to retrieving data from a knowledge store, is like what is that? Is it retrieving the data correctly? And all of these different set of quality metrics that we have. In addition to quality, we also have metrics for safety and like evaluating the risk. For example, is there a defect around a jailbreak, right? Like the typical scenario where you ask like to give you a recipe for like building some sort of like device, and then like you ask it nicely, tell me a story, and like you can like in not asking directly, and you can like do that break in the model. Like we have evaluators for those specific use cases. For language, for hate language, for sexual, for violence, for self-harm, like all of these are evaluators that we have. And the nice thing is that there is full control of like being able to like, you know, turn on and off those evaluators and the temperature on those evaluators. Why? Because there's specific use cases where there might be, like for example, if you're in the legal industry, a lot of the documents that are processed might contain information like, you know, violence, or might contain information about references about cases where like it's actually expected that the model will process those, right? Like so, this gives you as a developer the flexibility of like, you know, toggling those evaluators to your specific use cases. Now, in addition to that, for agents, we have the ones that we were showing around intent resolution, tool call accuracy, task adherence, and response completeness. And in terms of integrating all of those into your pipelines, right? Like the workflow is you have your data that is whether it's generated by test or whether you're you're capturing that data using store completions. You're using that that output through passing it through the evaluator. As I mentioned, we have LLMs as judges, like that produces the outputs of those evaluations, as we mentioned before, and then a set of visualizers. Then you can use the full integration into your CI/CD pipeline to complete that cycle as you take your application to prod.
Mm-hmm. So let's go take a look at some more of that. So before we jump to that, I wanted to show the tool call accuracy because I think this one's actually really interesting in terms of how you use evaluation. Tool call accuracy, we got a 0.25. The range here is 0 to 1, so this is clearly a miss. And let's try to figure out why together. So the first tool call, it says, that was pretty good. The second tool call does not address the user's full request and includes incorrect parameter values. And if we look at the traces, or we look at the data that was actually written out, we can see why. So this is the converted data. And if we look at here, it's calling the send email tool, but it's putting the customer's name, not their email address, as the email. So this is obviously not going to work. And actually, if we look a little more, what we'd realize is we never put email addresses in the invoice, so it doesn't know what those are. So this is, I think, a good reason to go run some evaluators.
Sounds good.
Cool. So
the next thing that you will do is integrate that into your pipelines. Mm-hmm. And you can do that with GitHub Actions in a very simple way. So let's show them.
Let's do it. So we can run the same thing just inside your CI/CD pipelines. So to do that, we have a new GitHub action for agent evaluators, just like the ones we saw a few minutes ago. Really, you just need a couple things. Of course, you need some credentials to Azure, and then you run the Azure AI, the AI agent evals action with info about your project, a deployment to use as the judge, the agent itself that you want to evaluate, like the ones we just built, and a path to some data. The data here is actually the inputs, it's not the full traces. So it's just like earlier we said, please generate some invoices, or look for overdue invoices and send emails. That would be the input in your action data JSON file.
So it's the test data.
Exactly. And then it runs the agent to get the outputs. And here's an example of actually how it's run in the past. So this is the same payment reminder agent that we've been working on. We get some operational metrics out, like how long it took, number of tokens, total. But then we also get the same evaluation things out, like intent resolution and task adherence. Both of those passed here. And if we had more data to work with, we could also get some confidence intervals on how close are we to being like a true pass or fail.
So every time that you make a change to your agent, you can pass it on to all your pipelines, get the validation, get the thresholds on your evals in order to like do the full integration into your rollout.
So every time you check in a new prompt or a change to your agent, you have assurance that it's going to work well.
Fantastic. Okay, so we demoed we talked about the inner loop, we talked about the outer loop. How do you make sure that like you go to take the use of like all of the different set of tools that we had available as you're going through the end-to-end of your developing journey? We went very much into code to show you like how you build an agent, how you use the Azure AI Foundry SDK, which is available in multiple languages, Python, C#, JavaScript, how you can use multiple models from the model catalog and use different models because they use the same API, the way to, you can easily change between models, how you can then add tools to agents, like we extensively use the code interpreter tool, how you can then evaluate them, and then how you take those into full integration into your pipelines to bring your app into production. Now, there's a lot of ways in which you can get started, but also it can feel like a blank canvas, just taking a model or like starting from a just brand new project from Visual Studio Code or like an agent. We also have a set of templates that we are announcing, and that like basically what we've done is taken a year worth of like the knowledge of customer data and like coming in from our field and the interactions that we have with our customers in terms of the set of scenarios that they want to build. And we've built those into templates so that you can get started faster for like some of those different set of scenarios that we're seeing like most commonly being used out in our customer base. Let's show them.
Let's take a look. So those are also available through the Foundry portal. I'm coming back here. On the left here is the templates tab. So we have a whole set here, like Yina mentioned, everything from just getting started, either with chat or completions or with an agent, all the way down to much more complex scenarios around multi-agent workflows, modernizing code, so converting SQL data, and advanced conversational understanding. So it's a great way to understand what does one of these look like in production. We deployed the Get Started with AI Agents template. If we look at the architecture, what it does is it deploys a container app, so both a front end and a back end. It uses the environment here as part of the isolation that we want. It logs the application insights like we've seen before. And it talks to the agent service on Foundry. So we took one of these, we deployed it with that same agent that we've built already, and let's take a look at how it looks like. When I browse to the URL, I get a simple chat interface, kind of thing I might give to my customers, and I can ask it questions too. Let's just ask about flooring and see what we get back. So behind the scenes, this is doing the same run agent as we always do. It gives us back some information. It can include citations. It can do other things for me. And we can customize the instructions for how we want this to look like for our customers.
So from an idea, blank canvas idea, to the templates where you can see like all of these starter, to like running it and deploying it in just a few minutes, you have an application that is being wired up with all of the agents, sending telemetry to App Insights, like doing the full thing end to end.
In less than an hour.
Well, the deployment, how much time did it take you to the deployment? Like
maybe 2 or 3 minutes.
There you go. So it's not in less than 5 minutes. Now you can have an app running using Azure AI Foundry and the entire stack of Azure, right? Like, because it's not just Azure AI Foundry that brings you models and agents and then set of capabilities, observability tools that you need to work with AI, but it fully integrates with the entire Azure stack, right? Like, you will be using containers maybe, you will be using Cosmos DB for your data, or Fabric, or you will be using Azure AI Search and all of these other services that come from Azure to like build your end-to-end solution. Alrighty, so with that, we're ending it a little bit early. Thank you so much. Hopefully this was useful to to share how you can go from an idea that you have to take AI into your application, how you can start as a developer who's like looking into that inner loop, how you have tools that are baked into Visual Studio with the Azure AI Foundry extension, where you can see the models, you can see the agents, you can use that to like in conjunction with the Azure AI Foundry SDK to like build your application end to end. And then once your application is built, take that application to production using evaluation, monitoring, leveraging the traces that are using OpenTelemetry, integrating with App Insights and Azure AI Insights and Azure Monitor, and then like, the full integration with your CI/CD pipelines in GitHub to make sure that every time that you make a change, you can get the outputs of like, what that change is bringing, and give you the confidence that you can actually deploy that new application to prod. Thank you so much for joining us. There's a whole bunch of resources that we have here for you to continue the learning path. As hopefully one of the takeaways that you take from our session today is that it only takes a few minutes to get started. We went very deep into like using multiple services, but it only takes a couple of minutes for you to just like go to ai.azure.com and start working with models and agents and the end-to-end for your solution. Thank you.
Thank you.